Welcome to Beam and Beyond. In this video, I'll solve problems 1, 2, and 3 from chapter 1 of Hibbeler's static book. Let's start with problem number 1. What is the weight in newtons of an object that has a mass of A, 8 kg, B, 0.04 kg, and C, 760 megagram? So when a numerical quantity is either very large or very small, we use prefixes to represent the number. I have table 1-3 here from page 9 of the book. This table presents the most common prefixes used in SI system. Also, to solve this problem, we are gonna need to know these information. So here we have Newton's law of gravitational attraction. F, which is force of gravitation between two particles. G, its universal constant of gravitation. M1 and M2 are the mass of the two particles, and R is the distance between the center of these two particles. So weight, by definition, is the downward force an object experiences due to gravity. So basically, it's the gravitational force between the Earth and an object close to the surface of the Earth. So this equation becomes F equals weight equals G, which is the universal constant of gravitation, times M, which is mass of the object, ME, mass of Earth, and R squared, which is the distance between the center of these two. As we know, G, ME, and R are all constant. So we can call this G, which is the acceleration due to gravity, and equals to 9.81 meters per second squared. I'm showing here how we get that 9.81. So based on all this information, we'll get to weight equals mass times gravitational acceleration. And the unit for weight is kilogram meters per second squared, which is by definition is 1 Newton. So 1 kilogram meter per second squared is 1 Newton. So let's solve the problem. So part A, we have M equals 8 kilogram. So weight equals mass times gravitational acceleration. Here we have 8 kilogram for M times 9.81 meters per second squared. And this will give us 78.5 kilogram meter per second squared, which based on this becomes 78.5 Newton. Let's move on to part B. Here we have M equals 0.04 kilogram. Again, weight equals mass times gravitational acceleration equals 0.04 kilogram times 9.81 meter per second squared. And this will give us 0.392 kilogram meter per second squared, which is Newton. 92 Newton. Let's move to part C. For part C, we have M equals 760 megagram. So as you can see up here from table 1-3, mega is 10 to the power of 6, and kilo is 10 to the power of 3. In SI units, when we are solving physical problems, we always need to make sure to use mass in kilogram. So 760 megagram equals 760 times 10 to the power of 6 grams, and that equals to 760 times 10 to the power of 3 kilogram. Now, weight equals mass times gravitational acceleration equals 760 times 10 to the power of 3 kilogram times 9.81 meters per second squared. This will give us 7.46 times 10 to the power of 6 kilogram meter per second squared. So again, based on table 1-3, 10 to the power of 6 is mega and kilogram meter per second squared is Newton. So this will give us 7.46 mega Newton. So this is our answer for part A, for part B, and for part C. Now, let me make this nice. Perfect. Now let's move to problem number 2. Represent each of the following combinations of units in the correct SI form. A. Kilonewton per microsecond. B. Megagram to millinewton. And C. Meganewton per kilogram millisecond. So, we have table 1-3 here, which are the most common used prefixes in SI unit system. Our goal here is to have no prefixes in the denominator. So in part A, we have kilonewton per microsecond. So here we have kilo equals 10 to the power of 3. And down here we have micro equals 10 to the power of -6. So we have 10 to the power of 3 for kilo, and we have 10 to the power of -6 for micro. Times, so we have -6 here, so times 10 to the power of 6, 10 to the power of 6. So the whole point is to get rid of that 10 to the power of -6 in the denominator. So this 10 to the power of -6 and 10 to the power of 6 cancel each other out, and at the top we'll have 10 to the power of 9 Newton over second. 10 to the power of 9 from table 1-3 is giga. So we'll have giga Newton per second. For part B, we have megagram per millinewton. So mega is 10 to the power of 6, and milli from this table is 10 to the power of -3. Times the unity fraction number. We have 10 to the power of -3. So times 10 to the power of 3, we'll get rid of that -3. So we'll have 10 to the power of 9 gram at denominator, and we'll have Newton at the denominator. And this will give us 10 to the power of 9 is gigagram per Newton. Let's move to part C. In part C, we have meganewton over kilogram millisecond. So mega is 10 to the power of 6 Newton kilogram.
times 10 to the power of minus 3 seconds. So the goal is to get rid of that 10 to the power of negative 3. 10 to the power of 3. This will give us 10 to the power of 9 Newton over kilogram second, which equals to 10 to the power of 9 is giga again, Newton over kilogram second. Let's highlight the final answers. Perfect. Now, let's move to the final problem in this video. Problem 1-3. Represent each of the following combination of units in the correct SI form. A, megagram per millisecond. B, Newton per millimeter. And C, millinewton per kilogram microsecond. Let's start with part A. For part A, we have megagram over millisecond. This equals to 10 to the power of 6 gram over 10 to the power of minus 3 second times 10 to the power of 3 over 10 to the power of 3 to get rid of that 10 to the power of minus 3. This will give us 10 to the power of 9 gram over second, which is gigagram per second. Part B. For part B, we have Newton per millimeter. Newton per millimeter. This equals to Newton per 10 to the power of negative 3 meter times 10 to the power of 3 again to get rid of that negative 3. This will give us 10 to the power of 3 Newton per meter. From table 1-3, 10 to the power of 3 is kilo. So we'll have kilonewton per meter. Let's move to part C. In part C, we have millinewton per kilogram times microsecond. Again, we don't mess with kilogram. This equals 10 to the power of negative 3 Newton over kilogram times 10 to the power of negative 6 second. Oops. Let me make this nicer. So we want to get rid of that 10 to the power of negative 6. So times 10 to the power of 6, 10 to the power of 6. This will give us 10 to the power of 3 Newton over kilogram second, which equals to 10 to the power of 3 is kilo Newton per kilogram second. Let's highlight our final answers. Perfect. And these are the answers we were looking for problem number 3.
Watch the next video for the following problems from this chapter. Like this video if you enjoyed watching it. Don't forget to subscribe if you are interested in learning statics with me. See you soon.